the chapter trigonometry. So if you see the term trigonometry, first three letters, that is tri. Tri means three. Tri means three. Gono. Gono means sides. Three sides. And metri is nothing but measurement. So it is the measurement of three sides. So if I consider a right angled triangle, consider a right angled triangle ABC. ABC is the right angled triangle which is right angled at A. That is, the angle at A is 90 degree. We know that this side BC makes some angle with the side BA. Let us call it as theta. And also here also there is some angle. Let us call it as alpha. So this is theta and this is alpha. We know that alpha as well as theta are acute angles. Those are acute angles. What are acute angles? If the angle is less than 90 degree, trigonometry majorly deals with the relationship between the angles as well as the sides. Now let me draw a right angle triangle. A, B, C, which is right angled at A. Now we have come across the term ratio. We know what is meant by ratio. So what is ratio? If I consider x divided by y, it is nothing but what? It is x is to 1. So this is one ratio. Similarly, we have trigonometric ratios. Before starting trigonometric ratios, let us name the sides of this right angled triangle. So you know that this angle is 90 degree. I will consider theta is the angle between CB and AB. So the side which is opposite to theta, which is the side opposite to theta? That is AC. AC is the side which is opposite to theta. That side is called as opposite side. Whereas the side which is opposite to 90 degree, is called as the hypotenuse. This is hypotenuse. And the remaining side is called adjacent side. Adjacent, and this is opposite hypotenuse as well as adjacent side. Now always the length of hypotenuse is always greater than the length of opposite as well as the adjacent side. So always hypotenuse is always greater than opposite side. Hypotenuse is always greater than the adjacent side. Because this is the application of the Pythagoras theorem. What does Pythagoras theorem says? The square of the hypotenuse is equal to the sum of square of the opposite other two sides. So if I apply the Pythagoras theorem here, we'll get BC square, that is the square of the hypotenuse, is equal to sum of the square of other two sides. That is CA square plus AB square. So consider a right angle triangle. So this is my right angle triangle ABC, which is right angled at A. Okay. The side which is opposite to A is called the hypotenuse. Side, if I consider theta is the angle, at B, then the side opposite to theta is CA, that is called as the opposite side, and the remaining side is called as the adjacent. Always remember, the adjacent side must contain that angle. Now the angle is at B, so adjacent side must contain B. So adjacent is nothing but AB. So if I consider the ratio of any two sides, first I will consider the ratio of opposite side as well as the hypotenuse. So opposite and the hypotenuse. Second, I will consider, so we can make, there are many possibilities to consider the ratios. So first possibility is opposite by hypotenuse. Second possibility is adjacent and the hypotenuse. So the ratio of adjacent side and the hypotenuse. And the third possibility is we can take the ratio of opposite side as well as the adjacent side. So opposite divided by adjacent. These are the first three possibilities. Which are the next three possibilities? Those are just the reciprocal of this first possibility. That is, I can take hypotenuse by opposite. I can take the ratio of hypotenuse by opposite. Second possibility is reciprocal of the hypotenuse and adjacent. And the third possibility is just the reciprocal of this one, that is adjacent divided by the opposite. So these are nothing but the ratios of that any two sides of a right angle triangle. There are no other possibilities. Totally there are 6 possibilities. Okay. The ratio of opposite and hypotenuse is called as sine theta. This is called as sine theta, where theta is the angle at B. The ratio of adjacent by hypotenuse is called as cos theta. Theta can be anything. Theta can be 30 degree, 45 degree, or in between, or 90 degree or 36 degree, anything. For any angle of theta, cos theta is given by adjacent by hypotenuse. And next, this is called as tan theta, the ratio of opposite and adjacent. Next, fourth one, I have taken just the reciprocal of this term. So this is called as cosec theta, C-O-S-E-C, cosecant theta. The full form is cosecant, but we are only considering the abbreviations, that is cosecant, cosec. Next one is, this one is the reciprocal of cos, that is called as secant or sec. It is nothing but secant. But we are only making use of the first 3 letters of that secant, that is sec theta. And this is the reciprocal of tan theta, isn't it? So that is nothing but cot theta. Now you have to remember all these formulas, but there is a trick to remember. Only try to remember the first 3 formulas. So how to remember? So first we are making use of the first letters, that is S, O, H, that is so, S, O, H. Second one, C, A, H, C, A, H. Third one, tan theta, T, O, A. So, kha, toa. Sine, opposite opposite by hypotenuse, cos adjacent by hypotenuse, and tan opposite by adjacent. Now, in order to remember this, we should know that sine and cosecant are reciprocals of each other. So, we can derive the formula for sine as well as cosecant, cos as and secant, tan and cot. So, one more formula, that is sine theta is equal to 1 by cosecant theta, or you can say cosecant theta is equal to 1 by sine theta. Second is the relation between cos and sec. So, cos theta is equal to 1 by secant theta. And the third relation is between tan and cot. So, tan theta is equal to 1 by cot theta. The reciprocal of cosecant theta is sin theta, or the reciprocal of cot theta is tan theta. So, these are the formulas you need to remember.